Hi, my name is ASYRAF HAIKAL bin Muhammad FITRI. You guys can call me ASYRAF. And my student ID is 2024263668.
Hi, my name is Amira QISTINA binti Muhammad Yuzri. You can call me by Amira. My student ID is 20244333974.
My name is Muhammad NURHAN bin IBERAHIM. You can call me Inas. My student ID is 2024405642.
Hello, and my name is Muhammad Ammar bin Muhammad JAFRI. My student ID is 20242607722.
What is the meaning of differentiation and what are the techniques of differentiation? Differentiation in mathematics is the process of finding the derivative of a function, which represents the instantaneous rate of change of that function. It essentially tells you how a function's output changes with respect to its input. There are several types of rules and techniques for differentiating functions.
So now we are going to discuss the second question. For this question, we need to find the dy dx for the following functions. For question A, which is 3x squared sec x plus 2. First step, we need to know which rule to use, and for this function, we will use the product rule, which is dy dx equal to f prime x gx plus fx g prime x. Next, we need to find the value of fx, f prime x, gx, and g prime x, where fx is 3x squared and gx is sec 2 plus x plus 2, and find the prime of each function using differentiation. After each value is differentiated, we can now substitute the value into the formula, which resulted in an equation of dy dx equals to 6x sec x plus 2 plus 3x squared times sec x plus 2 tan x plus 2. Finally, we simplify the equation, which will get us the final answer of dy dx equals sec x plus 2 times 6x plus 3x squared tan x plus 2. For question B, which is 4x plus 2 divided by cos x. First step, we will use the quotient rule for this function, which is dy dx equal to g prime x fx minus f prime x gx divided by gx squared. Next, we need to find the value of fx, f prime x, gx, and g prime x, where fx is fx 4x plus 2 and gx is cos x, and find the prime of each function using differentiation, which resulted in f prime x equal to 4 and g prime x equal to negative sin x. After each value is differentiated, we can now substitute the value into the formula, which resulted in an equation of dy dx equal to cos x 4 minus 4x plus 2 times negative sin x divided by cos x squared. Finally, we can simplify the equation, which will get us the final answer of dy dx equal to 4 cos x plus 4x plus 2 times sin x divided by cos square x.
In this problem, we are given the equation y ln 3x minus e power of 2x plus 1 minus tan for y equals 0, and we are asked to find dy over dx using implicit differentiation. Since y is a function of x, we must treat it accordingly and apply the chain rule and product rule where necessary. We start by differentiating each term of the equation with respect to x. The first term is y ln 3x. This is a product of two functions of x. So, we apply the product rule, which states that d uv over dx equal u dv over dx plus v du over dx. Let u equal y and v equal ln 3x. The derivative of y with respect to x is dy over dx, and the derivative of ln 3x with respect to x is 1 over x, since ln 3x equal ln 3 plus ln x, and the derivative of ln x is 1 over x. Using the product rule, the derivative of y ln 3x becomes y over x plus ln 3x multiplied with dy over dx. Next, we differentiate the second term, which is e power of 2x plus 1. This requires the chain rule. The derivative of e power of u is e power of u multiplied with du over dx. So here we get e power of 2x plus 1 multiplied with 2 equal to e power of 2x plus 1. Then we differentiate the third term, tan for y. Again, using the chain rule, the derivative of tan u is sec square u multiplied with du over dx. So we get sec square for y multiplied with 4 multiplied with dy over dx, which simplifies to 4 sec square for y multiplied with dy over dx. Now that we have differentiated all three terms, we substitute the results back into the equation. This gives us y over x plus ln 3x multiplied with dy over dx minus 2e power of 2x plus 1 minus 4 sec square for y multiplied with dy over dx equals 0. Next, we want to solve for dy over dx. To do this, we group the terms that contain dy over dx on one side of the equation and move the rest to the other side. We combine ln 3x multiplied with dy over dx minus 4 sec square for y multiplied with dy over dx equal to e power of 2x plus 1 minus y over x. Now, we factor out dy over dx from the left hand side. Dy over dx multiplied with ln 3x minus 4 sec square for y equal to e power of 2x plus 1 minus y over x. Finally, we isolate dy over dx by dividing both sides by the expression in brackets. Dy over dx equal to e power of 2x plus 1 minus y over x over ln 3x minus 4 sec square for y. And that's our final answer. We have successfully found dy over dx by applying implicit differentiation, carefully using the product rule and chain rule, and rearranging the resulting expression algebraically. This step-by-step process shows the importance of treating y as a function of x throughout the differentiation.
Next, I will show you how to solve question 4, which is to estimate the value of fourth root of 80.99 minus 2 over square root of 80.99 correct to 3 decimal using linear approximation. For this question, first we need to find x sub 0 and delta x. X is the given value, which we will take from the root. So x is 80.99. X sub 0 is the chosen value, which is the value closest to 80.99. So x sub 0 is 81. Delta x is equivalent x minus x sub 0. Substitute values and we will get negative 0.01. Next, we have to find fx sub 0, equivalent to fourth root of x sub 0 minus 2 over square root of x sub 0. Sub the value of x sub 0 into the equation. It will become f81 equivalent to fourth root of 81 minus 2 over square root 81, equivalent to 3 minus 2 over 9, and we will get 25 over 9. Then, we have to differentiate fx sub 0. So, f prime x sub 0 is equivalent to x sub 0 to the power of 1 over 4 minus 2x sub 0 to the power of negative 1 over 2. We take the power to the front and minus the power by 1, which will become 1 over 4 x sub 0 to the power of negative 3 over 4 minus x sub 0 to the power of negative 3 over 2, and equivalent to 1 over 4 fourth root of x sub 0 cube minus 1 over square root x sub 0 cube. Next, sub the value of x sub 0. f prime 81 equivalent to 1 over 4 fourth root of 81 cube minus 1 over square root 81 cube. Calculate the denominator first, and we will get 1 over 4 times 27 minus 1 over 729 minus the values, and we will get 23 over 2916. Now, we will use the formula, which is fx sub 0 plus delta x equivalent to fx sub 0 plus f prime x sub 0 delta x. Subs the values. Fx sub 0, 25 over 9 plus f prime x sub 0, 23 over 2916 times delta x, negative 0.01. Calculate using a calculator, and the final answer would be 2.778.
Differentiation is an important topic in calculus that is required to be learned as it helps us to understand how things change, especially regarding values of functions. It is also essential for solving problems regarding rates of change, determination of graph, and also applied it to solve real-life matters like estimation, motion, and also growth.